All right, everybody, hello and welcome back. Today what we're going to do is we are going to work on solving some quadratic functions, paying particular attention to the discriminant value, and then we are going to briefly talk about vertical motion. So let's jump right in here. We are going to solve three quadratics right off the bat. We've got 2x squared plus 12x plus 16 is equal to 0. Now this is already set equal to 0, so I'm going to divide out a GCF. We get x squared plus 6x plus 8 is equal to 0. And now I'll plug into that quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I can simplify that discriminant value to get 36 minus 32 is 4 over 2. So here's my discriminant value. It is a positive number. It is 4. So we can actually go ahead and simplify from there. X equals negative 6 plus or minus 2 over 2. Looks like I've got a little bit delete there. So now I can finally simplify and get my solution. Negative 6 plus 2 is negative 4 over 2 is negative 2. And then negative 6 minus 2 is negative 8. Divided by 2 would be negative 4. So these are my two solutions for this quadratic. If I wanted to, I could quickly sketch the graph, which would have two x-intercepts being my two solutions of negative 4, 0 and negative 2, 0 as those x-intercepts. All right, so a pretty standard situation here. My discriminant is positive 4, so I have two real solutions. Now, in our next situation, it's a little bit of an easier quadratic, but we're again going to jump right into the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And you know what? This should be a positive 1 right at the end, which makes this a positive 1 there. So I can simplify to get x equals 2 plus or minus the square root of, well, I end up with 4 minus 4, which is 0 over 2. So my discriminant essentially becomes nothing, 0. And that means when we're solving, I don't really need the square root because the square root of 0 is 0. And that therefore means I don't need the plus and the minus, right? Plus 0 minus 0 doesn't really change anything. So my solution is only 2 over 2 or 1. So this quadratic has one solution, which means the graph is going to look similar to this. One solution, therefore one x-intercept. Now our last situation here is we have 5x squared minus 7x plus 4. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we simplify that discriminant to get x equals 7 plus or minus the square root of. We'll have 49 minus 80, it looks like, right? 4 times 5 is 20. 20 times 4 is 80. So that should leave us with 31 as our discriminant, negative 31 that is, divided by 10. So again, a little bit of a different situation here. Our discriminant is now negative. So what that should tell us with all the work we've been doing lately is we are going to have imaginary solutions. Now if I take a look, I am not able to simplify this radical anymore. So this is actually going to be our solution. X equals 7 plus or minus the square root of negative 31 over 10, which, you know what, I should really change to x equals 7 plus or minus I root 31 over 10. Because we do know that every time we take the square root of a negative, we have an imaginary solution. So just like the other ones, I'm going to quickly look at the graph here, and what's going to end up happening is I am going to have something similar to this, and I'm not putting a whole lot of time looking into that graph. I know I have a positive y-intercept, but I do not have any x-intercepts, and that's because our solutions are imaginary. That means they are not real, so we have no real x-intercepts. So these are kind of the three situations we wanted to point out here. We've got our first example that has a discriminant value that is greater than 0. It is positive. And we end up with two real solutions. Now, those might be rational numbers like they are here, or they could be irrational values that still have the square root with them. But the point is we will have two solutions to x-intercepts. Then we have our middle situation where our discriminant value is 0. What that leads us to is only having one x-intercept. And if we take a look at that quadratic formula, it's because, again, that plus or minus essentially disappears along with the square root, because adding or subtracting the square root of 0 is doing nothing to our solution. All right, and then finally we have our solution at the end, which has a discriminant value that is negative and tells us we are going to have imaginary solutions and no x-intercepts. So it's important to remember when our discriminant is greater than 0, we're going to have two solutions and two x-intercepts. When that discriminant value is equal to 0, we're only going to have one x-intercept. And then finally, when that discriminant value is less than 0, we have no real solutions and no x-intercepts. Now, that's an important idea for us because it kind of leads us into our next part, which is our vertical motion problems. So we have our equation here, h of t is equal to negative 16t squared plus v sub 0 times t plus s sub 0, where v sub 0 is our initial velocity and s sub 0 is our initial height. So you've got a situation here. It says a ball is thrown into the air with an initial velocity of 30 feet per second when leaving the person's hand 4 feet above the ground. Write the equation for the height of the ball in terms of time. So the height in terms of time is going to be negative 16 t squared plus our initial velocity, which is 30 feet per second, times t plus that initial height, which is 4 feet. So this equation here represents the path or the height of the ball as it is thrown into the air. Now we can quickly sketch the graph, and I'm not going to put a whole lot of time going into it. It's going to look something like this, where we've got a y-intercept of 4, and then we have our vertex, our x-intercept, and all of our other points. Now it says, use your graph. Will the ball reach a height of 10 feet and then 25 feet? Well, in order to do this, what we have to do is figure out what that value is in the middle, what our vertex value is. And the reason it is our maximum point. So it will tell us what the maximum height is, whether it's 10, 25, or some other number. And this will allow us to answer that question. Now, the problem here is we don't really want to have to do all that work. I am always trying to make our job as easy as possible. So instead of having to use our x equals opposite of b over 2 times a formula, which I'm sure we all remember, to plug back in and then find the height at my vertex, instead, I can use what we now know about our discriminants. What we know about our discriminant is if the discriminant evaluates to a positive number, that means we have two real solutions. If it evaluates to 0, we have one real solution. And if the discriminant evaluates to a negative number, we have no real solutions. So let's use that information. We have our equation here. And what we can do is we can essentially start to solve to find out the time where our height will equal where our height will equal 10 feet. So I am plugging in 10 for my height, and what I can do is set my quadratic equal to 0 like we are going to solve. And now I can plug into my quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now I'm going to simplify a little bit, but I'm only really focused on our discriminant at the moment. So we have 30 squared, which should give us 900. But then we have minus 4 times 16 times 6, which is going to be a minus 384 all over negative 32. So I can simplify one more time, even though we're not officially done solving, but I have 900 minus 384, which gives us the square root of 516. Now, here's the idea. Using what we just talked about, my discriminant value is positive 516. It is a positive number, so it tells me I'm going to have two real solutions. So the answer here is yes. We do have a time of which our ball will reach 10 feet in the air. And now the question doesn't ask us when, it just says will it. So I can actually stop here. Now we can answer 25 in the exact same fashion. Set our quadratic equal to 25 and evaluate the same way. So I'm going to subtract over my 25 to get 0 equals negative 16t squared plus 30t minus 21. So I can plug into that quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And again, I'm going to simplify to get negative 30 plus or minus the square root of. That'll be 900 minus 4 times negative 16 times negative 21, that should be, is 1,344. Now, if I simplify one more time, just so we can make our next step abundantly clear, we have 900 minus 1,344, which is negative 444 as our discriminant value. Now, my discriminant is negative. That means my solutions are going to be imaginary. What that tells me is there's only imaginary inputs or time values of which the ball will reach a height of 25 feet. So that tells me there is no real time that the ball will reach 25 feet, and therefore our answer here is no. All right, so these vertical motion problems are pretty similar to what we used to do before, but now we are using what we know about the discriminant value to answer the question as quickly as possible without having to actually solve for the values that would make this situation true. Okay? The big takeaways for the day are the discriminant values. If it is positive, we have two real solutions. If it is 0, we have one real solution. And if it is negative, we have none. Okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out.